Hello guys, this is Code and Code and this is first lecture of string theory series. In this lecture we are going to study sliding window algorithm for string matching. So let's continue. So what are we gonna learn in this lecture? First of all, we'll be learning what is string um, sliding window algorithm, and then we'll be going on for the C++ implementation of sliding window algorithm. After that, we'll be learning the time complexity of the algorithm, and finally I'll be providing you one practice problem to practice your newly learned algorithm. So let's get started. First, what is sliding window algorithm? To answer this question, let's learn the problem statement of the problem which is solved using sliding window algorithm. So the problem is you are given a text T and a pattern P. You have to find whether pattern P exists in text T or not. Text T means it can be anything, a string, a simple line, or a paragraph, anything. And then there is something that you want to find, like whether in that line or in text this pattern like phone, phone exists or not, or certain number, or like you text can be your C++ program, and you may need to find whether cin exists in that program or not. So text can be anything in which you want to perform search, and this pattern is what you want to search in this text. So if pattern exists in the text, you have to print all of the occurrences of the pattern in the text. If I show you, if I explain you with the same with an example, so suppose the text is Code and Code is the best resource for competitive programming, and the pattern is code. If you apply the search on the text, you'd find that COD appears at two different positions. Here COD appears at this position and then here. Now what I have printed is the starting position of the occurrence. Okay, so COD appears here and the starting position would be 0. We are using index, zero based index system, so it is appearing. You will most likely, if you are asked to print, you will be asked to print the starting position where the pattern is occurring. So starting position is 0 and 5. That is why I have printed 0 and 5. Similarly, if I explain you with one more example, now we are searching for small c and small o, and this appears at these two position, and their corresponding indices I have printed here as an output. So this is the problem statement which is used which is solved using sliding window algorithm. Now if you want to learn algorithm at advanced level, you want to get started with competitive programming, or you want to learn some advanced level of algorithm, you can always go for an academy. An academy have variety of courses on competitive programming, like on game theory, on number theory, on graph theory, on dynamic programming, and so on. So you will be learning from the experts, of course, and all of the courses are online, so you can watch it on your phone or on your desktop. So if I show you some of the you can always go and try some of the free classes, and these are some of the free classes that will be launched today, like advanced problem solving on, I think this is on segmentary, because below on the top left corner you can see GSS 7, which is a segmentary problem on spot. So this most likely be advanced problem solving on segmentary, and how to start your placement and so on. This is some over subset, which is a DP technique. So these are some of the free lectures that you can always go and check out, and you can see whether these guys are worth investing your money or not. And these are the teachers, the experts that will be teaching you. These are these have been software engineer at Google or LinkedIn and so on. So these are pretty good guys. Now these are the if you go for the free lectures, you can see these are the test series and free lectures. Go ahead and check out free lectures and see for yourself how do these guys teach. And finally, when you see that yes, these guys are good, which most likely should be, because of course these are experienced guys, then you can always go for the subscription, either 1 month, 6 month or 12 month subscription, and you can apply my code _UA and get 10% off on the subscription. So let's head back to our lecture. So now what we were discussing is this is the problem statement that we will be solving using sliding window algorithm, right? So how does it work? How the sliding window algorithm works? So as the name might have suggested, you look through the window and compare only what you can see through it. So what do I mean by that is this. Now here you see this is the text cabbage uses cab, and this is the pattern that we want to search. So you can see I've marked all of the characters indices, so it is easy to print out the answer. So you can see the output should be 0 because CAB is appearing at position 0 as well as 13, so the output should be 0 and 13. But here we are going to learn how sliding window algorithm actually works. Now this consider the text as the whole word and this as your window. The pattern will act as your window, and you can see only that much what your window allows, because you are seeing through your window. Now when you look at the pattern, only these three characters or these three only these three characters of the text are visible. So what you will be doing, you will be comparing the first character of the visible world to the first character of pattern, second character of visible world to the second character of the pattern, similarly and so on, and the last character of the visible world to the last character of the pattern. So we see here that the first character of text and the first character of the visible world matches the first character of pattern, and so on and so forth for the rest of the character as well. So we see there is a matching, and that is why if there exists a matching, you'd be printing the index of the first character of visible world, which is 0 in this case. Then now what you do, you would move your window towards right position by one character. Now we are here. Now we do the exact same thing. Now only these characters of the world are visible. So I'll be comparing the first character of visible world to the first character of pattern, but here we see that A and C does not match. So I do not need to match the rest of the character, and I can simply move my window towards the left again, and then I'll try to compare these. But again, the first character of visible world does not match the first character of the pattern, so again there is a mismatch. So I'll be proceeding further, and I'll be keep doing this till I reach this point, because nothing from here to here would match. Finally I'm here, and now again the first character of visible world matches the first character of pattern, similarly the second and third. So I can print the index of the first character of the visible world, which is 13. So the output I'm printing is 0 and 13, and finally we'll stop because there is no space for the window to go right. So this is how your sliding window algorithm works. So you start from the very beginning and keep moving your window towards right, and each time comparing the current visible world with the pattern. If matches, print the index of the first character of visible world, otherwise just move the window towards the right. Now it's time for C++ implementation of the algorithm, but before that